What if a massive asteroid suddenly struck Earth and completely destroyed 15 major countries? The world map could change forever. In this video, we'll explore what could happen to these countries, how the impact might affect the rest of the world, and what Earth could look like afterward. Stay until the end. The final scenario is shocking. Before we begin, don't forget to like, share, and subscribe for more amazing space and science videos. Imagine an ordinary morning across the United States. Millions of people are going to work. Students are heading to school. Airplanes are crossing the skies. And cities are beginning another normal day. Nobody realizes that something enormous is approaching Earth from deep space. Far beyond the moon, an asteroid is traveling at an incredible speed. And its trajectory is slowly bringing it closer to our planet. Astronomers operating powerful telescopes detect a strange object moving through space. At first, it appears to be another ordinary near-Earth asteroid, but after several observations, scientists calculate its orbit and discover something terrifying. The asteroid's projected path intersects with Earth. More calculations reveal that the United States could be directly within the impact region. Scientists immediately begin studying the asteroid size, mass, speed, composition, and trajectory. These factors determine how much energy would be released during an impact. A relatively small asteroid might cause devastating regional destruction, while a much larger object could create consequences extending far beyond the United States. Every new observation becomes critical because even a small change in its trajectory could alter where it eventually. Once scientists become sufficiently confident that an impact is possible, emergency agencies and governments would begin preparing. Authorities would have to communicate an incredibly difficult message to the public without creating unnecessary panic. Evacuations might begin in areas expected to experience the strongest effects, but the amount of warning time would depend entirely on when the asteroid was discovered and how accurately its trajectory could be predicted. As the news spreads, television networks, social media, and emergency alerts would be flooded with information about the approaching asteroid. Millions of people would try to understand what is happening and whether their communities are safe. Roads could become heavily congested as people attempt to leave threatened areas. At the same time, emergency services would have to deal with misinformation, panic, and enormous demand for transportation, food, water, and shelter. If scientists had enough warning, authorities could attempt large-scale evacuations. Major highways, airports, railways, and other transportation systems could become extremely busy. However, evacuating an entire region or an entire country would be practically impossible on a short timeline. The priority would likely be protecting people closest to the predicted impact zone and preparing shelters and emergency services farther away. Eventually, the asteroid would become visible as it entered Earth's vicinity. As it moved closer, its speed and brightness would increase dramatically. The object would be carrying an enormous amount of kinetic energy. From the ground, people might see an extremely bright object crossing the sky. The asteroid would slam into Earth's atmosphere at tremendous speed. Air resistance would heat the surrounding atmosphere and could cause the asteroid to fragment or partially break apart, depending on its composition. A strong shockwave could form around the object as it rapidly pushes through the air. The sky near the trajectory could become dramatically brighter than normal. Then comes the most destructive moment, the impact itself. When the asteroid collides with the ground, its kinetic energy is converted into heat, pressure, shockwaves, and enormous geological forces. The result would depend heavily on the asteroid size and where it struck. Near the impact site, the environment could be transformed within seconds. The impact would produce an enormous explosion-like release of energy Rock and soil could be instantly heated and thrown outward at tremendous speeds. A powerful blast wave would move away from the impact point, potentially destroying structures over a huge area. The closer an area was to the impact, the more extreme the destruction would become. A sufficiently large asteroid could excavate a massive crater in the Earth's surface. Rock from deep underground could be blasted into the atmosphere. If the asteroid struck the ocean instead of land, the consequences would be different but potentially devastating. An enormous impact could displace huge quantities of seawater and generate powerful waves. Coastal regions could face severe flooding depending on the asteroid size, impact location, ocean depth, and distance from the affected coastlines. The extreme heat generated by a major impact could ignite fires across affected regions, burning buildings, vegetation, fuel supplies, and other materials could create enormous fire zones. In a sufficiently large impact scenario, smoke and atmospheric particles from these fires could add to the electricity networks could be heavily damaged by the direct effects of the impact and by widespread destruction of infrastructure, power stations, transmission lines, substations, and communication systems could become unavailable. Without electricity, hospitals, water treatment systems, transportation networks, and communication infrastructure would face serious firefighters, police officers, medical teams, rescue workers, and emergency organizations would suddenly face a disaster far beyond the scale of ordinary emergencies. Roads could be blocked by debris, communication systems could fail, and hospitals could become overwhelmed. Even areas far from the impact zone might have to absorb displaced populations and provide humanitarian assistance. Modern society depends heavily on interconnected communication systems, cell towers, internet infrastructure, satellites, fiber optic networks, and power systems could all experience disruptions. People separated from their families might struggle to communicate, while authorities would have difficulty distributing reliable information during the crisis. If the asteroid were sufficiently large, the impact could send enormous quantities of dust, rock particles, and other material high into the atmosphere. Some of these particles could remain suspended for an extended period. This is where a major asteroid impact could transition from being primarily a regional disaster into a potentially global environmental event. A sufficiently large amount of atmospheric dust could reduce the amount of sunlight reaching Earth's surface. The sky could become unusually hazy or dark in affected regions. The severity and duration of this effect would depend strongly on the asteroid size, impact location, composition of the target material, and the amount of material injected into the atmosphere. If sunlight were significantly reduced for an extended period, global temperatures could temporarily decline. This would not happen equally everywhere, and the effect would depend on the scale of the impact. A truly massive asteroid could potentially trigger substantial climate disruption, while a smaller asteroid would have much more limited global effects. A disaster on this scale would not only be about the initial destruction. Transportation networks, farms, warehouses, fuel supplies, water systems, and supply chains could all be disrupted. Communities might face shortages of essential goods, making organization, cooperation, and humanitarian assistance extremely important. The United States is deeply integrated into global finance, manufacturing, transportation, technology, energy, and trade. A catastrophic impact could therefore create enormous economic disruption. Financial markets could experience extreme volatility. Businesses could shut down, supply chains could break, and other countries could immediately feel the consequences. The effects would not remain inside America's borders. Countries around the world depend on American goods, technology, financial systems, energy markets, agriculture, and international trade. A major disruption could affect currencies, stock markets, shipping, manufacturing, and international supply chains, creating a worldwide economic crisis. Other nations and international organizations would face the challenge of responding to an unprecedented humanitarian disaster. Countries could send emergency supplies, medical teams, rescue equipment, food, and other assistance. At the same time, governments would have to protect their own populations from possible global economic and months and years after the impact. The consequences could continue. Rebuilding destroyed infrastructure would require enormous resources, while displaced populations would need housing, food, healthcare, and employment. If the asteroid were large enough to cause global climate disruption, humanity could face an even greater challenge of adapting to a dramatically changed environment. But there is one important question. Could humanity stop such an asteroid before it reaches Earth? Scientists are already studying near-Earth objects and developing planetary defense technologies. Missions such as NASA's DART demonstrated that an asteroid's motion can be altered through a deliberate spacecraft impact. With enough warning, accurate tracking, and suitable technology, humanity may one day be able to prevent some dangerous asteroids from striking Earth. India wakes up to another normal day. Trains are moving, highways are crowded, cities are busy, and millions of people are starting work. But high above Earth, an enormous space rock is moving silently toward the planet, and nobody knows yet that its path could lead directly toward. At an observatory, scientists notice an unusual object among the countless bodies traveling through space. Its orbit is studied again and again. As more observations arrive, the calculations become increasingly concerning. This isn't simply a flyby. There is a possibility that the asteroid could collide with Earth. Researchers begin working around the clock to determine the object's dimensions and trajectory. They need to know exactly where it could strike and how much energy it could release. Even a difference of a few hundred kilometers in the predicted path could completely change which regions face the greatest danger. Government agencies receive the warning. Scientific organizations and emergency authorities begin discussing possible responses. The difficult part is that an asteroid cannot simply be stopped by evacuating one neighborhood. The potential danger could cover an enormous area depending on the asteroid size. Suddenly, the entire country hears the same terrifying headline. An asteroid could be heading toward Earth. Social media explodes with videos, theories, rumors, and speculation. People begin calling their families, checking news updates, and trying to understand how much time remains. If scientists' evacuation plans could begin, but India has enormous population centers, dense cities, major highways, rail networks, and huge transportation demands. Moving millions of people away from a predicted impact region would be one of the greatest logistical challenges imaginable. As the asteroid approaches, the atmosphere becomes tense. Scientists continue refining its predicted trajectory while authorities monitor the situation. Somewhere above Earth, the asteroid is getting closer with every passing second. The object eventually reaches the atmosphere. At incredible speed, it compresses and heats the air around it, producing a brilliant trail across the sky. Depending on its composition, the asteroid could partially break apart, but if it is large enough, much of it could continue toward the surface. The asteroid finally reaches its destination. In a fraction of a second, an enormous amount of kinetic energy is released. The impact zone would experience extreme heat and pressure, while material from the Earth's surface would be violently thrown outward. The resulting explosion would be unlike an ordinary industrial accident or conventional explosion. A powerful pressure wave would race through the atmosphere, Everything near the impact location would face extreme forces, while damage would gradually decrease with distance. A sufficiently large impact could carve an enormous depression into the Earth's surface. The crater would become a permanent geological feature. Rocks from deep underground could be thrown into the atmosphere, and the landscape surrounding the impact would be radically transformed. The energy wouldn't remain concentrated at ground zero. A huge atmospheric disturbance would spread outward, depending on the asteroid's energy and the surrounding terrain. Distant areas could experience damaging winds and pressure. If the impact happened near a major Indian city, densely packed infrastructure could dramatically increase the destruction. Roads could become impassable, buildings could be damaged, transportation could stop, and emergency responders could struggle to reach people trapped in affected areas. The impact would launch rock and dust high above the surface. Some material would fall relatively close to the impact zone, while finer particles could travel much farther. The falling debris would create another dangerous phase of the disaster. The impact would send powerful vibrations through the ground. Structures already weakened by the blast could suffer additional damage. Underground infrastructure, bridges, tunnels, pipelines, and other systems could also be affected. Now imagine the asteroid striking the Indian Ocean instead. Instead of primarily creating a giant land crater, the collision would violently displace seawater. Coastal regions could face dangerous waves, with the severity depending on the impact's distance from shore, ocean depth, and asteroid size. The impact's intense heat could ignite widespread fires. Industrial facilities, vehicles, forests, buildings, and fuel storage areas could all contribute to the flames. In heavily populated areas, fighting these fires would become extremely difficult if roads and water systems were damaged. Power infrastructure could be knocked offline across severely affected regions. Without electricity, communication towers, hospitals, water pumps, railway systems, and essential industries could stop functioning. The disaster would therefore continue even after the asteroid itself had disappeared. Medical centers would suddenly face enormous numbers of injured people. Supplies, beds, medicines, electricity, and medical personnel could become limited. Hospitals outside the impact zone could also become overwhelmed. As survivors travel toward safer regions, India's modern communication network depends on electricity, fiber connections, cellular towers, data centers, satellites, and other infrastructure. Damage to multiple systems could cause major communication blackouts, making it difficult for families and authorities to stay connected. The biggest concern would come if the asteroid were extremely large. Massive quantities of material could be pushed high into the atmosphere. Some of this material could spread far beyond India, potentially affecting atmospheric conditions across large parts of the planet. If enough particles entered the upper atmosphere, they could scatter or block some incoming sunlight. The result could be unusual skies and reduced solar radiation. The effect would depend on the scale of the impact rather than simply the fact that an asteroid hit India. A very large impact could temporarily disturb Earth's climate. Temperatures, rainfall patterns, and atmospheric conditions could change. The larger the asteroid, the greater the possibility that the consequences would move from a national emergency toward a global environmental crisis. India depends heavily on agriculture, and crops require suitable sunlight, temperature, water, and seasonal conditions. A major atmospheric disruption could interfere with these factors. Farmers could face declining yields while transportation and storage systems are simultaneously struggling. If agricultural production falls while transportation networks are damaged, food distribution becomes much harder. Major cities would need reliable supplies from unaffected regions. Governments would face the enormous task of protecting food reserves and ensuring essential supplies reach vulnerable communities. India's economy is connected to almost every major part of the global system. Manufacturing, IT services, pharmaceuticals, transportation, energy, finance, and exports could all be disrupted. The financial consequences could continue for years depending on the scale of the destruction. A disaster of this magnitude would not be an Indian problem alone. International companies depend on Indian production and services, while many countries rely on India for medicines, technology, manufacturing, and other goods. Global supply chains could experience serious disruptions. A disaster of this magnitude would not be an Indian problem alone. While many countries rely on India for medicines, technology, manufacturing, and other goods, global supply chains could experience serious disruptions. Even after the immediate danger disappears, rebuilding would be an enormous undertaking. Roads, bridges, homes, hospitals, power systems, industries, and communication networks would need to be reconstructed. The social and economic consequences could continue for decades. The most important part of this scenario isn't simply imagining the destruction. It's asking whether it could be prevented. Detecting dangerous asteroids early gives humanity the best chance to respond. Technologies such as NASA's DART mission have already shown that an asteroid's trajectory can be deliberately changed, giving future generations a potential defense against one of nature's most powerful threats. Astronomers discover a previously unnoticed asteroid moving through deep space. Initial observations suggest it is large enough to become dangerous if its trajectory brings it close to Earth. As more observations are collected, scientists calculate the asteroid's orbit with greater accuracy. A potential collision zone begins to appear, and parts of the Philippines fall within the predicted path. Scientists would study the asteroid's dimensions, speed, density, and composition. These factors would determine how much energy it could release and whether it would survive atmospheric entry. Philippine authorities would coordinate with astronomers, disaster response agencies, and international organizations. Maps of potentially affected regions would become essential for deciding where emergency preparations should begin. News of the asteroid would spread across the country. Manila, Cebu, Davao, and communities throughout the many Philippine islands would be watching for updates as scientists refine the prediction. The Philippines' geography would create a major challenge. Thousands of islands mean that moving people, supplies, and emergency equipment could require a combination of roads, ships, aircraft, and airports. If the asteroid were detected years in advance, authorities might have time to prepare large-scale evacuation plans. If the warning came much later, moving millions of people could become almost impossible. The object finally reaches Earth's atmosphere. Friction and compression heat the surrounding air, creating an enormous glowing trail that could be visible from a vast distance for observers far from the impact point. The asteroid could appear as an incredibly bright object crossing the sky. Seconds later, the collision would unleash the destructive energy that scientists had feared. At the collision site, extreme heat and pressure would rapidly destroy the surrounding environment. Rock and soil could be pulverized and thrown outward at tremendous speeds. If the asteroid were large enough and struck land, it could create a massive crater. The surrounding terrain could be permanently transformed, with enormous quantities of material thrown into the atmosphere. A powerful shockwave would spread from the impact zone. Buildings, vehicles, roads, bridges, and other structures could be damaged progressively farther from the point of impact. If the impact occurred near Metro Manila, the consequences could be especially severe. The region's enormous population and concentration of infrastructure would make rescue and evacuation extraordinarily difficult. Debris, damaged bridges, Collapsed structures and abandoned vehicles could make roads difficult to use. Emergency responders would need to clear routes while simultaneously transporting injured people and essential supplies. Electricity infrastructure could be damaged by the blast, fires, or ground disturbances. Extended power failures would affect hospitals, communications, water systems, transportation, and businesses. In asteroids striking the surrounding ocean would create a different type of catastrophe. A sufficiently large impact could displace huge quantities of seawater and generate powerful waves. Low-lying coastal communities could be particularly vulnerable to waves and flooding. Ports, fishing areas, resorts, airports, and coastal roads could suffer severe disruption depending on the impact location. If ports and airports were damaged, some islands could become temporarily isolated. Delivering food, medicine, fuel, and rescue equipment would become one of the biggest challenges. The impact's extreme heat could trigger fires across affected areas. Urban buildings, vehicles, industrial facilities, and damaged electrical systems could all contribute to secondary fires. Hospitals would face huge numbers of injured people while potentially dealing with damaged infrastructure and shortages. Medical facilities outside the main impact region would become vital emergency centers. Authorities would need to communicate evacuation orders and safety information quickly, but damaged communication towers, power failures, and overloaded networks could make it difficult for people to receive reliable information. The Philippines depends on complex transportation networks to move food between islands. Damage to roads, ports, ships, warehouses, and markets could create shortages even in areas that escaped direct destruction. Farmland could be damaged by the immediate impact and its aftermath. If a very large asteroid injected significant dust into the atmosphere, reduced sunlight could create additional problems for crops. The Philippines, beaches, islands, resorts, and diving destinations attract visitors from around the world. A catastrophic event could severely damage tourism infrastructure and create massive economic losses. A major collision could contaminate local landscapes with debris and dust. Rivers, forests, coastal ecosystems, and marine environments could all be affected depending on where the asteroid struck. The consequences could extend beyond the Philippines through disrupted shipping, trade, migration, and atmospheric effects. Neighboring countries could face economic and humanitarian challenges. As the disaster unfolded, the Philippines is connected to international manufacturing, shipping, electronics, agriculture, and trade networks. A catastrophic disaster could therefore create disruptions far beyond Southeast Asia. Other countries and international organizations could provide aircraft, ships, medical teams, emergency supplies, food, and financial assistance. Coordinating this aid across thousands of islands would be a huge logistical operation. Recovery would require rebuilding homes, roads, bridges, airports, ports, hospitals, power systems, and communication networks. The most severely affected regions could take many years to recover. The best defense would be stopping the asteroid before it reaches Earth early. Detection could give scientists years to study the object and potentially alter its trajectory using planetary defense technology. In this scenario, the most important battle would happen millions of kilometers away in space. Astronomers detect a large object moving through the solar system. It appears to be an asteroid, but its trajectory is unusual. More observations are needed before scientists can determine whether Earth is actually in danger. After tracking the object for several days, researchers discover that its projected path could intersect with Earth, Indonesia, appears within one of the possible impact corridors, turning a distant astronomical event into a potential national emergency. Researchers would study the asteroid size, mass, speed, composition, and rotation. These details would determine whether it could survive its journey through the atmosphere and how much energy might be released during a collision. Once the threat becomes credible, Indonesian authorities would need to work with scientists and international organizations. Emergency planners would begin examining possible impact areas and preparing responses for different scenarios. The information would spread rapidly across Indonesia, from Jakarta and Surabaya to smaller cities and remote islands. People would be searching for updates. Social media could quickly become filled with both accurate information and dangerous. Indonesia is an enormous archipelago made up of thousands of islands. This geography could make evacuation extremely complicated. Moving large populations between islands would depend heavily on ships, aircraft, airports, ports, roads, and available fuel. If scientists had enough warning, authorities could begin relocating people from the predicted impact zone. But even with modern transportation, moving millions of people away from danger would be an extraordinary logistical challenge. Eventually, the asteroid reaches Earth's atmosphere. It would travel at an incredible velocity, compressing the air around it and generating enormous heat. From the ground, it could appear as a spectacular but terrifying fireball. If the asteroid reaches the surface, the collision would release tremendous energy almost instantly. The impact area would experience extreme temperatures and pressure, while enormous quantities of material are thrown outward. A large asteroid could excavate a gigantic crater. If it struck land, soil, rock, and other material could be blasted away from the impact point, permanently changing the landscape. The collision would create a powerful atmospheric pressure wave. Nearby structures could be devastated, while more distant areas could experience severe winds and pressure, depending on the asteroid's size. If an asteroid struck close to the Jakarta metropolitan region, the consequences could be enormous. Dense development, transportation networks, power systems, and communication infrastructure could all be affected simultaneously. Damage to airports, harbors, bridges, roads, and communication systems could leave some communities temporarily isolated, supplying food, medicine, fuel, and rescue equipment to remote. A massive collision would send seismic energy through the Earth's crust. The resulting ground motion could damage buildings and infrastructure well beyond the immediate impact area. Indonesia is surrounded by vast areas of ocean, making an offshore impact another possibility. If a sufficiently large asteroid struck the sea, it could violently displace enormous quantities of water. An ocean impact could generate powerful waves that threaten coastal settlements. The actual effects would depend on the asteroid size, impact location, water depth, and distance from the coastline. Indonesia relies heavily on maritime transportation. Severe damage to ports could disrupt the movement of food, fuel, machinery, and other essential goods between islands and with international markets. The heat and destruction could ignite fires across urban and industrial regions. Electrical equipment, vehicles, fuel facilities, buildings, and vegetation could all add to the danger. Electricity infrastructure could be damaged by the blast, fires, seismic activity, or falling debris. Large-scale outages would affect homes, hospitals, communication networks, water systems, and businesses. Medical facilities would suddenly face an enormous number of casualties. Hospitals outside the most severely damaged regions would become critical centers for emergency treatment. But transporting patients could be extremely difficult. Communication becomes essential during the aftermath. People would need reliable instructions about evacuation routes, shelters, food, water, and dangerous areas. Damaged telecommunications infrastructure could make coordination much harder. A disaster of this magnitude could severely affect manufacturing, tourism, agriculture, shipping, energy, and trade. Businesses across unaffected regions could also suffer because transportation and supply networks would be disrupted. Indonesia's famous beaches, islands, resorts, and cultural destinations attract visitors from around the world. A catastrophic impact could devastate tourism infrastructure and cause enormous economic losses. Indonesia depends on agriculture across many regions. Damage to farmland, irrigation, transportation, storage, and markets could reduce food availability. A very large impact could create additional problems if atmospheric conditions changed. If the asteroid were exceptionally large, huge quantities of dust and vapor could enter the upper atmosphere. Some of this material could travel thousands of kilometers, potentially affecting weather and atmospheric conditions far beyond Indonesia. A massive amount of atmospheric debris could block or scatter some sunlight. If the effect were strong enough, temperatures and growing conditions could change temporarily, creating additional pressure on agriculture and ecosystems. Indonesia's location between the Indian and Pacific Oceans means a major catastrophe could have regional consequences. Disrupted shipping, atmospheric effects, migration, and economic instability could affect neighboring countries. International organizations and foreign governments could send medical teams, emergency equipment, food, water, aircraft, and financial assistance. Because Indonesia is an archipelago, international air and maritime support could become especially important. Recovery would be an enormous undertaking. Roads, ports, airports, hospitals, power networks, homes, businesses, and communication systems across multiple islands could need reconstruction. The process could take many. The most important part of this scenario happens before impact. If a dangerous asteroid is discovered early enough, scientists may have years to study its trajectory and attempt to change its course. Planetary defense technology has already demonstrated that an asteroid's motion can be altered, meaning early detection could potentially save an entire country from a cosmic disaster. Astronomers discover a large asteroid approaching the inner solar system. Initial observations show that its orbit could eventually bring it dangerously close to Earth. As observatories collect more data, scientists realize that Australia lies within one of the possible impact corridors. The asteroid immediately becomes an international priority. Researchers measure its size, speed, density, rotation, and composition. These details would determine how much destructive energy it could release. Australian authorities would begin working with astronomers and emergency agencies. Scientists would continuously update the predicted impact zone as new observations arrived. People in Sydney, Melbourne, Brisbane, Perth, Adelaide, and other cities would closely follow the situation. The country would wait for one crucial question: where exactly will it hit? If enough warning existed, authorities could prepare evacuation routes, emergency shelters, hospitals, aircraft, and supply networks. Australia has enormous distances between major population centers, moving large numbers of people away from an impact zone could therefore require extensive use of highways, railways, airports, and aircraft. As the asteroid approaches Earth, telescopes would track it almost continuously. Its apparent brightness would increase as it moved closer. The asteroid enters Earth's atmosphere at tremendous speed. Air compression creates extreme temperatures around it, producing a spectacular fireball visible across a huge region. If the asteroid reaches Australia's surface, enormous kinetic energy would be released within seconds. The immediate impact region would experience extreme heat, pressure, and destruction. A sufficiently large impact could excavate a massive crater, rock and soil would be blasted into the surrounding atmosphere, permanently changing the terrain. The collision would create a powerful atmospheric pressure wave. Structures, vehicles, roads, and other infrastructure could be severely damaged over a wide area if the impact occurred close to a major Australian city. The concentration of people and infrastructure would make the disaster significantly more difficult to manage. Australia's highways would become essential evacuation and rescue routes. Debris, fires, damaged bridges, and traffic congestion could make transportation extremely difficult. A large asteroid impact would send seismic energy through the crust. Strong ground movement could damage infrastructure beyond the immediate impact zone. Australia is surrounded by enormous ocean areas. An offshore impact could create a different chain of events, particularly for coastal communitisa sufficiently large asteroid striking. The ocean could displace huge quantities of seawater. The resulting waves could threaten vulnerable coastal. If a major offshore impact occurred near Australia's eastern coastline, coastal infrastructure, ports, roads, and populated areas could experience severe consequences. Extreme heat from the impact could ignite vegetation, buildings, vehicles, and industrial facilities. Fires could become a major secondary disaster. Damage to power stations, transmission lines, and substations could cause widespread outages. Communication, hospitals, water systems, and businesses would all be affected. Medical centers would face an enormous demand for emergency treatment. Hospitals outside the main impact region could become critical facilities for. Australia has many remote communities separated by vast distances. If roads, airports, or communication systems were damaged, delivering emergency supplies could become extremely difficult. Australia's farms and livestock regions could be affected by direct destruction, fires, debris, and transportation failures. Damage to food production areas could create wider supply problems. Australia's mining sector is deeply connected to global supply chains. A major disaster could interrupt mining operations, transportation, exports, and international markets. Australia's beaches, cities, forests, reefs, and wildlife destinations attract visitors from around the world. A catastrophic event could severely damage the tourism industry. Australia's unique ecosystems could be heavily affected by fire, debris, flooding, and habitat destruction. Some species could face serious long-term environmental pressure. If the asteroid were exceptionally large, enormous amounts of dust and vapor could enter the atmosphere. Some of this material could spread far beyond Australia. A catastrophic Australian impact could disrupt international trade, mining exports, food supplies, shipping, and financial markets. The consequences could therefore extend far beyond the country. Recovery could require rebuilding roads, airports, hospitals, power networks, ports, homes, industries, and damaged ecosystems. Depending on the scale, restoration could take years or even decades. The most important part of the story happens before the asteroid reaches Earth. Early detection could give scientists time to calculate its trajectory, and the safest asteroid impact is the one humanity prevents. A faint object is detected moving through the darkness of space. Astronomers initially have no reason to believe it is dangerous, but repeated observations reveal that the object is heading toward the inner solar system. Scientists calculate thousands of possible trajectories using observations from different locations. Eventually, one troubling possibility emerges. Japan lies within the potential impact corridor. Researchers begin examining everything they can determine about the object: its size, rotation, density, composition, and velocity. These characteristics could determine whether it breaks apart in the atmosphere or reaches the surface with enormous energy. Once the threat becomes credible, Japanese authorities would begin coordinating with scientists, emergency organizations, and international space agencies. The country would have to prepare for an event unlike any conventional natural disaster. People across Tokyo, Osaka, Nagoya, Yokohama, Sapporo, and countless smaller communities would suddenly be confronted with the same terrifying possibility. News broadcasts and smartphones would become the primary sources of information. Japan already has extensive experience preparing for earthquakes, tsunamis, typhoons, and other hazards. Emergency systems could become extremely valuable, but an asteroid impact would be on an entirely different scale. If there were enough warning, authorities could attempt to move people away from the predicted danger zone. Japan's dense cities and limited land area would make a massive evacuation extremely complicated. The asteroid continues closing the distance between itself and Earth. Telescopes around the world monitor its movement while scientists refine the impact prediction. At this stage, even a small change in trajectory could dramatically alter the outcome. The asteroid enters Earth's atmosphere at tremendous velocity. Air compressed around the object becomes incredibly hot, producing a brilliant fireball. People across a huge area could potentially see the event. Depending on the asteroid size and trajectory, the asteroid finally strikes. An enormous amount of kinetic energy is released almost instantly, producing extreme heat, pressure, and a violent disturbance in the Earth's surface. A large enough asteroid could excavate a massive crater and permanently reshape the impact region. Rocks and soil would be thrown outward while material from underground could be blasted high into the atmosphere. A powerful atmospheric pressure wave would expand from the impact site. Structures close to the collision would face the most severe effects, while buildings farther away could experience progressively weaker but still dangerous pressure. If the impact occurred anywhere near the Tokyo metropolitan region, the consequences could be enormous because of the area's population density and complex infrastructure. Roads, railways, communications, power networks, and high-rise buildings could all be affected. Japan's extensive railway system is a crucial part of everyday life. Damage to tracks, stations, tunnels, bridges, power systems, and signaling infrastructure could bring transportation to a standstill in affected areas. The collision would transfer enormous energy into the Earth's crust. Powerful seismic waves could spread outward and potentially damage infrastructure well beyond the immediate impact region. Because Japan is surrounded by the Pacific Ocean and other seas, an offshore impact would create another possible disaster scenario. A sufficiently large asteroid hitting the ocean could displace tremendous amounts of water. If an ocean impact generated large waves, coastal communities could experience severe flooding. Ports, industrial zones, roads, airports, and coastal cities could be particularly vulnerable depending on the impact location. The heat generated by a major impact could ignite fires across affected regions. Urban areas could become especially difficult to manage if damaged electrical systems, fuel supplies, and industrial facilities contribute to the flames. Japan's electricity network could experience major disruption in regions affected by the blast, fires, seismic activity, or debris. Losing power would immediately affect hospitals, communications, transportation, water systems, and businesses. Medical centers would face an enormous number of casualties while potentially dealing with damaged facilities and limited supplies. Hospitals outside the impact region would become essential for treating people evacuated from severely affected areas. Japan depends heavily on maritime transportation. Damage to major ports could interfere with imports of food, fuel, raw materials, and other necessities. Restoring port operations would, therefore, become an important part of the recovery. Japan's advanced technology could help with communication, robotics, mapping, and disaster response. But technology still depends on electricity, functioning infrastructure, and communication networks. A sufficiently large impact could overwhelm even sophisticated. If the asteroid were exceptionally large, enormous amounts of dust and vapor could enter the upper atmosphere. Some of this material could travel far beyond Japan and potentially influence conditions across the planet. A major amount of atmospheric debris could reduce the sunlight reaching Earth's surface. The sky could become darker or hazier, and temperatures could potentially change if the disturbance were large enough. Japan already relies significantly on imported food and raw materials. A major disruption to agriculture, shipping, transportation, and international trade could place additional pressure on food supplies. Japan plays an important role in advanced manufacturing, electronics, automobiles, machinery, materials, and industrial technology. A major catastrophe could interrupt production and affect companies and industries around the world. A disaster affecting one of the world's major economies would create immediate uncertainty across global markets. Insurance, shipping, manufacturing, currencies, and investment could all experience severe disruption. International organizations and governments would likely organize humanitarian assistance, medical teams, emergency equipment, food, temporary shelters, and financial resources could be sent to support Japan during the crisis. Once the immediate danger passed, Japan would face the enormous task of rebuilding damaged cities and infrastructure, restoring transportation, electricity, communications, housing, industries, and coastal facilities could take on the scale of the impact. But the most important moment would happen long before the asteroid reached Earth. Early detection could provide humanity with valuable time to respond. Modern planetary defense missions have shown that spacecraft can alter an asteroid's trajectory, meaning that finding a dangerous asteroid early enough could potentially turn a catastrophic impact into a near miss. Astronomers detect a large asteroid moving through the inner solar system. At first, there is no reason to panic, but its orbit requires closer observation. After additional observations, scientists calculate that the asteroid could potentially intersect Earth's orbit. Bangladesh appears within one of the possible impact regions. Researchers estimate the asteroid's diameter, velocity, density, and composition. These measurements determine whether it could explode in the atmosphere or reach the ground with enormous energy. Once the probability becomes significant, authorities would begin emergency preparations. Scientists would provide updated impact projections while disaster response teams assess vulnerable. News would spread rapidly through television, smartphones, and social media. Dhaka, Chattogram, Khulna, Rajshahi, Sylhet, and other cities would be waiting for the next. Bangladesh has a very high population density, making a large-scale evacuation extremely difficult. Roads, railways, waterways, and available shelters would be placed under enormous pressure. As the asteroid gets closer, astronomers would repeatedly update its trajectory. Every new observation could make the predicted impact area more precise. The asteroid finally enters Earth's atmosphere at tremendous speed. The surrounding air heats dramatically, producing a brilliant fireball that could be visible across a huge region. If the asteroid reaches the surface, an enormous amount of kinetic energy would be released almost instantly. The immediate impact zone would experience extreme heat, pressure, and rapidly expanding debris. A sufficiently large asteroid could create a huge crater. Rock, soil, and other material would be blasted outward. dramatically transforming the surrounding landscape. The collision would generate a massive pressure wave. Buildings and infrastructure near the impact could be destroyed, while more distant areas could experience severe structural damage. If the impact occurred near Dhaka, the consequences could be especially serious because of the city's enormous population and concentration of roads, businesses, communications, and essential services. Even without direct destruction, evacuation traffic could create enormous congestion. If bridges or major roads were damaged, moving people and emergency supplies would become even harder. A major impact would send seismic energy through the Earth's crust. Strong ground motion could damage structures beyond the immediate blast zone. Bangladesh has an extensive coastline along the Bay of Bengal. An offshore asteroid impact would create a completely different scenario, potentially involving powerful waves. A sufficiently large asteroid hitting the ocean could displace enormous quantities of seawater. The resulting waves would depend heavily on the asteroid size, impact location, and distance from Bangladesh. Low-lying coastal areas could be particularly vulnerable to flooding. Ports, fishing communities, roads, settlements, and agricultural land could all be affected. The Sundarbans, one of the world's largest mangrove forests, could face severe environmental disruption from extreme coastal flooding or a nearby impact. Extreme heat and damaged infrastructure could trigger widespread fires. Buildings, vehicles, electrical equipment, and industrial facilities could become additional sources of danger. Power stations, transmission lines, and substations could be damaged. Large-scale outages would affect hospitals, communication networks, water systems, businesses, and homes. Medical facilities would have to treat enormous numbers of injured people. Hospitals outside the worst-hit areas could become crucial centers for emergency treatment. Damage to water treatment facilities and distribution networks could create serious problems. Providing clean drinking water would quickly become a major emergency priority. Bangladesh's agricultural regions could be affected by direct destruction, flooding, debris, and transportation failures. Damage to rice-producing areas could create additional food security challenges. Bangladesh's major manufacturing and garment sectors depend on factories, workers, electricity, roads, ports, and international shipping. A catastrophic impact could interrupt this entire damage to major port infrastructure could severely disrupt imports and exports. Restoring maritime transportation would become essential for bringing food, fuel, medicine, and other supplies into the country. If the asteroid were extremely large, enormous amounts of dust and vapor could enter the atmosphere. Some of this material could spread across South Asia and potentially much farther. A major atmospheric disturbance could reduce the amount of sunlight reaching Earth's surface. If significant and prolonged, this could affect temperatures and agricultural growing conditions. The disaster would not necessarily remain within Bangladesh. Disrupted trade, migration, food supplies, transportation, and atmospheric effects could create consequences across neighboring countries. Once the immediate crisis ended, Bangladesh would face the enormous task of rebuilding homes, hospitals, roads, bridges, ports, factories, power systems, and agricultural infrastructure. The most important opportunity would come before the asteroid reached Earth. If astronomers discovered it early enough, planetary defense missions could potentially alter its trajectory. In the end, the greatest protection for Bangladesh would be detecting the asteroid before it becomes a threat. Astronomers notice a large asteroid moving through the solar system. Its orbit brings it unusually close to Earth, so observatories begin tracking it continuously. As new measurements arrive, scientists realize that the asteroid's path could cross Southeast Asia. Malaysia becomes one of the countries included in the potential impact corridor. researchers determine its approximate size, mass, speed, rotation, and composition. These factors would decide how much energy the asteroid could release if it reached Earth. Once the probability becomes significant, Malaysian authorities would begin coordinating with scientists and disaster response agencies. Possible impact zones would be studied carefully. News would spread rapidly across Kuala Lumpur, Johor Bahru, Penang, Ipoh, Kota Kinabalu, Kuching, and other parts of the country. Malaysia has highly developed transportation networks, but moving huge numbers of people away from a predicted impact zone would still be extremely difficult. Emergency shelters, hospitals, roads, airports, and communication systems would become central to the national response. As the countdown continued, the approaching asteroid would eventually enter Earth's atmosphere at tremendous speed. The surrounding air would become intensely heated, creating a brilliant fireball. People far from the impact zone could potentially see the asteroid crossing the sky. Within moments, the event would transform from an astronomical spectacle into a major disaster. If the asteroid survived atmospheric entry, its impact would release enormous energy in a fraction of a second, generating extreme heat, pressure, and debris. A sufficiently large land impact could excavate a massive crater and throw rocks and dust high into the atmosphere. A powerful pressure wave would spread outward from the impact. Buildings and infrastructure near the impact would face the greatest destruction. If the impact occurred near Kuala Lumpur, the dense metropolitan region could experience severe disruption to roads, communications, electricity, businesses, and emergency services. Malaysia's highways, railways, airports, and bridges would become crucial for evacuation and rescue operations. Damage to even a few major routes could create serious bottlenecks. A large impact would transfer tremendous energy into the Earth's crust. Seismic waves could damage structures far beyond the immediate impact zone. Malaysia's position between the South China Sea and the Strait of Malacca introduces another possibility. An offshore impact, a sufficiently large ocean impact could displace enormous quantities of seawater. Coastal areas could face dangerous waves depending on the impact location and asteroid size. Major ports are essential to Malaysia's economy. Severe damage could disrupt shipping, imports, exports, fuel supplies, and emergency deliveries. The intense heat and damaged infrastructure could trigger fires in urban and industrial areas. Emergency crews would face multiple disasters. Power stations, substations, and transmission lines could be damaged. Extended outages would affect hospitals, water supplies, communications, transportation, and homes. Medical facilities would have to handle large numbers of casualties while possibly operating with damaged buildings and limited electricity, water, and supplies. Damage to treatment plants and pipelines could interrupt clean water distribution. Emergency authorities would need to rapidly provide safe drinking water. Malaysia's plantations, farms, fisheries, and food distribution networks could be disrupted. Damage to roads and ports could make moving food between regions difficult. Malaysia is an important part of regional electronics and manufacturing supply chains. A major disaster could interrupt factories and affect companies around the world. Malaysia's cities, islands, beaches, forests, and cultural destinations attract millions of visitors. Major destruction could severely damage the tourism industry. A major impact could destroy surrounding ecosystems. Forests, rivers, wildlife habitats, and coastal environments could suffer long-lasting consequences. If the asteroid were exceptionally large, dust and vapor could rise high into the atmosphere, Some of that material could spread across Southeast Asia. Malaysia's trading connections mean the consequences could extend beyond its borders. Shipping, manufacturing, food supplies, and regional economies could all be affected. Once the immediate crisis ended, rebuilding could involve highways, railways, airports, ports, hospitals, power networks, factories, homes, and damaged ecosystems. Recovery could take years. The most important defense would come before the asteroid reached Earth. If detected early enough, scientists could study its trajectory and potentially use planetary defense technology to alter its path. The safest asteroid impact is the one humanity prevents. Astronomers detect a large asteroid approaching the inner solar system. Its trajectory initially appears uncertain, so observatories around the world begin monitoring it closely. After more observations, scientists discover that the asteroid's potential impact corridor crosses South America. With Brazil inside the area of concern, researchers calculate its size, mass, speed, density, and composition. These characteristics would determine how much energy could be released during an impact. Brazilian authorities would coordinate with scientists and emergency agencies. Possible impact regions would be mapped while international observatories continue tracking the asteroid. People across São Paulo, Rio de Janeiro, Brasilia, Salvador, Belo Horizonte, and other cities would watch the rapidly developing situation. If scientists had enough warning, authorities could prepare evacuation routes, shelters, hospitals, airports, and emergency supply centers. Brazil is enormous, meaning the distance between cities and remote regions could make a nationwide emergency response extremely complicated. As the asteroid gets closer, telescopes would monitor it almost continuously. Scientists would narrow down the predicted impact location. The asteroid enters Earth's atmosphere at extraordinary speed. Friction and compression heat the surrounding air, creating a brilliant fireball. If the asteroid reaches the surface, an enormous amount of energy would be released almost instantly. The immediate impact area would face extreme heat, pressure, and debris. A sufficiently large asteroid could excavate a gigantic crater, throwing rock and soil high into the atmosphere and permanently changing the landscape. A powerful blast wave would spread outward from the impact. Buildings, vehicles, roads, bridges, and infrastructure could suffer increasing damage with proximity to the impact. If the impact occurred near São Paulo, the enormous population and concentration of transportation, industry, businesses, and infrastructure would make the disaster exceptionally difficult to manage. A nearby impact could severely affect Rio's dense urban areas and coastline. Damage to roads, airports, ports, and communications could complicate rescue operations. A major impact would send seismic energy through the Earth's crust. Strong ground movement could damage structures well beyond the immediate blast zone. An offshore impact would create a different scenario. A sufficiently large asteroid striking the Atlantic could displace enormous quantities of seawater. Depending on the impact location and asteroid size, powerful waves could travel toward parts of Brazil's extensive coastline. Ports, beaches, roads, residential areas, and industrial facilities near the coast could be affected by severe flooding and debris. Extreme heat from the impact could ignite vegetation, buildings, vehicles, and industrial facilities. Fires could become a major secondary emergency. Power stations, substations, and transmission lines could fail. Widespread blackouts would affect hospitals, communications, water systems, transportation, and businesses. Medical centers would face huge numbers of injured people. Hospitals farther from the impact zone would become essential for treating casualties and supporting evacuation. Highways, railways, airports, and ports could be damaged or overwhelmed. Moving emergency teams and supplies across such a large country would be a massive challenge. Brazil is one of the world's major agricultural producers. Damage to farms, storage facilities, roads, and export infrastructure could create serious food and supply chain disruptions if the impact occurred. Near the Amazon region, enormous fires, debris, atmospheric disturbances, or other environmental effects could threaten one of Earth's most important. Brazil's mining, manufacturing, energy, and industrial sectors could experience major interruptions. Damage to railways and ports could further affect exports, forests, rivers, wetlands, coastlines, and wildlife habitats could suffer from fire, flooding, debris, and atmospheric changes. If the asteroid were exceptionally large, dust and vapor could rise into the atmosphere and spread across South America and potentially much farther. Brazil plays a major role in global agriculture, mining, energy, and trade. A catastrophic impact could therefore disrupt international markets and supply chains. Recovery could require rebuilding cities, highways, ports, airports, hospitals, farms, power systems, industries, and ecosystems. Depending on the scale, restoration could take many years. The most important battle would happen long before the asteroid reached Brazil. If detected early enough, planetary defense missions could potentially alter its trajectory. The best asteroid impact is the one humanity prevents, far beyond Earth's atmosphere. Astronomers notice an unfamiliar object moving through the solar system. At first, nobody knows exactly what it is or where it is going. Additional observations reveal that it is a large asteroid, traveling on a trajectory that could eventually bring it dangerously close to Earth. Scientists compare observations collected from different telescopes and calculate the asteroid's future path. The predicted orbit gradually becomes more precise, and Pakistan appears within the potential impact corridor. Suddenly, an astronomical discovery becomes a national emergency. Researchers would need to determine the asteroid's diameter, density, composition, speed, and exact trajectory. These measurements would help estimate how much energy the collision could release. Even a small change in the predicted path could determine whether the asteroid hits land, mountains, desert, or once the probability of impact becomes significant. The information would be passed to national emergency authorities, scientific agencies, disaster response organizations, and government departments would begin working together. Their first objective would be understanding exactly which regions could face the greatest danger. The announcement would immediately attract television channels, and social media platforms would be filled with updates. People across major cities and rural communities would try to understand whether they should stay where they are or attempt to move somewhere safer. Pakistan's geography would play a major role in the outcome. Mountains, plains, deserts, densely populated cities, rivers, and coastal areas would respond differently to an asteroid impact. The exact location would therefore be just as important as the asteroid's size. If scientists provided enough warning, authorities could attempt to relocate people from the predicted danger zone. But moving large populations would be incredibly difficult. Roads could become congested, fuel supplies could become limited, and millions of people might attempt to travel at the same time. Eventually, the asteroid would approach the Earth. Scientists would continue tracking it until the final moments. Around the world, telescopes would be watching the object while emergency teams waited for the outcome of the final trajectory. Calculations. As the asteroid enters the atmosphere, it would encounter enormous resistance from Earth's air. The surrounding atmosphere could become extremely hot, producing an intense glowing trail. Depending on the asteroid's structure, it could fragment or continue toward the surface as a large body. The asteroid finally reaches Pakistan. The impact would occur in an incredibly short period of time, but the energy released could be enormous. Rock beneath the asteroid would be crushed and heated while material from the surface would be thrown violently into the surrounding environment. Near the point of collision, the environment would experience the strongest effects. Extreme pressure, heat, and rapidly moving debris could destroy structures and dramatically alter the terrain. The surrounding area could become almost unrecognizable compared with what existed there before. If the asteroid were large enough, the collision could excavate a massive crater. Material from underground would be blasted upward and outward. The resulting geological formation could remain for an extremely long time, becoming a permanent reminder of the event. The impact would generate a powerful atmospheric disturbance. A pressure wave would spread away from the impact site, with its strength decreasing as it traveled. Areas farther away could still experience damaging winds and pressure, depending on the asteroid's energy. Structures within the affected region could suffer severe damage. Windows, roofs, walls, bridges, communication towers, and other infrastructure would be vulnerable to powerful pressure and debris. Buildings already weakened by the initial disturbance could experience additional failures. The collision would also send energy through the Earth's crust. Strong seismic waves could travel outward from the impact zone. Roads could crack, bridges could be damaged, and underground systems such as pipelines and tunnels could be. If the impact occurred near the Indus River system, the consequences could become especially complicated. Damage to transportation, agriculture, water infrastructure, and settlements along the river could create additional challenges. Flooding and debris could further complicate emergency operations, depending on the exact impact conditions. In offshore, collision would produce a completely different scenario. A sufficiently large asteroid striking the Arabian Sea could violently displace seawater. Coastal areas could experience powerful waves and flooding, although the actual severity would depend heavily on impact size, location, depth, and distance from the shoreline. Extreme temperatures and damaged infrastructure could trigger widespread fires. Urban areas, industrial facilities, vehicles, fuel storage, and electrical equipment could all contribute to the flames. Firefighters would face enormous difficulties if roads, water supplies, and communication systems were already damaged. The disaster would not end when the asteroid disappeared from the sky. Electricity, telecommunications, transportation, water distribution, and other essential services could be disrupted. Communities outside the immediate impact zone could suddenly become crucial. Hospitals would have to handle a huge number of emergency cases while potentially dealing with shortages of electricity, medical supplies, transportation, and staff. Medical facilities in safer regions would also face pressure as injured and displaced people moved away from the disaster zone. Highways and railways would become essential for moving survivors, food, medicine, fuel, and rescue equipment. But damaged bridges, collapsed structures, debris, and traffic congestion could make transportation extremely difficult. Restoring major transport routes would become one of the highest priorities. Becomes a lifeline during the aftermath. Reliable information would be extremely important. Authorities would need to communicate evacuation instructions, locations of shelters, emergency supplies, and safety information. Any widespread failure of mobile or internet networks could make coordination much harder. If the asteroid were extremely large, the collision could send enormous amounts of dust and vapor high into the atmosphere. Some particles could spread far beyond Pakistan. This is where a regional catastrophe could potentially begin developing. Global environmental consequences Very large quantity of atmospheric material could interfere with incoming sunlight. The sky could become unusually hazy, and Earth's surface could receive less solar energy. The scale of this effect would depend on the asteroid and the material thrown into the atmosphere. Pakistan's agricultural regions could be affected by changes in temperature, sunlight, rainfall, and atmospheric conditions. Crops already facing damage from the immediate disaster could then encounter longer-term environmental difficulties. Food production could therefore become a major concern. Damage to water infrastructure could create additional pressure on communities. Clean drinking water would become essential for both survivors and emergency responders. Maintaining water treatment and distribution systems would become a critical part of the recovery effort. A disaster on this scale could severely disrupt factories, businesses, transportation, agriculture, energy production, and trade. Markets could react immediately, while rebuilding costs could continue rising for years. The economic impact would depend heavily on the asteroid's size and where it. The consequences would not necessarily stop at Pakistan's borders. Disrupted trade, migration, environmental effects, and regional supply shortages could affect neighboring countries. International organizations would likely face a major humanitarian coordination challenge. Once the immediate danger had passed, the enormous task of reconstruction would begin. Homes, roads, bridges, hospitals, power networks, communication systems, businesses, and agricultural infrastructure would need to be restored. Recovery could take years or much longer. For the most severely affected regions, the most important lesson from this fictional scenario is that asteroid impacts can be monitored before they happen. Detecting a dangerous object decades in advance could give humanity time to study it and potentially alter its trajectory. Planetary defense missions have already demonstrated that spacecraft, meaning early detection. Astronomers detect a massive asteroid traveling through space. Its orbit is calculated repeatedly as scientists try to determine whether it could eventually cross Earth's path. New observations narrow down the possible collision area. Parts of Canada now appear inside the predicted corridor, turning an astronomical discovery into a potential national emergency. Researchers measure the asteroid size, speed, density, rotation, and composition. Even a small change in these measurements could dramatically change the predicted impact location. Canadian authorities would begin coordinating with scientists and emergency agencies. The public would receive information about the potential threat while experts continued monitoring the asteroid. Toronto, Montreal, Vancouver, Calgary, Ottawa, and other major cities would begin reviewing emergency plans. Hospitals, transportation networks, shelters, and communication systems would become critical. Canada's geography creates a challenge. Canada is enormous, with vast distances between populated regions. Moving people away from a predicted impact zone could require enormous coordination across highways, railways, airports, and remote routes. The countdown accelerates as the asteroid approaches. Astronomers would track it more frequently. Every new observation would help determine exactly where the object could strike. The asteroid enters Earth's atmosphere at extraordinary speed. The surrounding air becomes superheated, creating a brilliant fireball. Visible from enormous distances, the asteroid would cross the atmosphere in a matter of seconds. Its enormous kinetic energy would make the final moments almost impossible to comprehend from the ground. If it reached Canada's surface, the impact would release tremendous energy almost instantly. The immediate region would experience extreme heat, pressure, and rapidly expanding debris. A large enough asteroid could excavate an enormous crater. Rock and soil would be thrown into the atmosphere while the surrounding landscape is permanently transformed. a powerful pressure. Wave would travel outward from the impact. Structures, vehicles, roads, bridges, and other infrastructure could be damaged across a huge area. If the impact occurred close to a densely populated Canadian city, the concentration of buildings, transportation networks, and essential services would make the disaster far more difficult to manage. Canada's cold climate could make emergency response especially challenging during winter. Power failures, damaged roads, freezing temperatures, and disrupted heating could create additional dangers. A major collision would send seismic waves through the Earth's crust. Strong ground motion could affect areas far beyond the immediate impact site. An asteroid striking Canada's Atlantic or Pacific coastal waters could create a different scenario. Ocean displacement could become an additional threat to coastal communities. A sufficiently large offshore impact could generate powerful waves. The severity would depend on the asteroid size, impact location, water depth, and distance from populated areas. Canada relies heavily on major ports for international trade. Damage to coastal infrastructure could disrupt shipping, fuel supplies, food imports, and industrial activity. Extreme impact temperatures could ignite forests, buildings, vehicles, and industrial facilities. Firefighters would face an overwhelming challenge if communications and transportation were also damaged. Transmission lines, substations, and generating facilities could be affected. Large-scale blackouts would disrupt heating, water systems, hospitals, communications, and businesses. Medical facilities would have to treat huge numbers of injured people. Hospitals outside the impact zone would become essential centers for emergency treatment. And Canada has many communities separated by enormous distances. If roads, airports, or communication networks were damaged, reaching remote populations could become extremely difficult. Farms and food production regions could be affected by direct destruction, fires, debris, and transportation failures. Damage to agricultural infrastructure could create shortages. Canada's energy sector takes a hit. Canada's oil, gas, electricity, and mining industries are deeply connected to the national and global economy. A catastrophic impact could disrupt production and transportation. Canada's forests, lakes, wetlands, and wildlife habitats could suffer from fire, debris, flooding, and atmospheric changes. Ecosystems near the impact could take decades to recover if the asteroid were exceptionally large. Enormous quantities of dust and vapor could enter the atmosphere. These particles could travel far beyond Canada. A major atmospheric dust cloud could temporarily reduce sunlight reaching the surface. If the effect were significant, temperatures and agricultural conditions could change. Canada's role in energy, mining, agriculture, manufacturing, and international trade means a catastrophic impact could affect global markets and supply chains. After the immediate crisis, Canada would face years of reconstruction. Roads, railways, airports, hospitals, power systems, homes, industries, forests, and damaged communities would all need restoration. The real defense against an asteroid is early detection. If scientists discover a dangerous object early enough, planetary defense missions could potentially change its trajectory. The greatest victory would be preventing the asteroid from reaching Canada at all. Far beyond the moon, a telescope detects a faint object moving against the background stars. At first, it looks like an ordinary asteroid, but as astronomers track it over several nights, its trajectory starts raising. Serious. New observations allow scientists to calculate the asteroid's future path. The numbers reveal a disturbing possibility. The asteroid could cross Earth's surface somewhere near Sri Lanka. Researchers would need to determine its approximate diameter, mass, speed, shape, and composition. These details would help estimate whether it would burn up, break apart, explode in the atmosphere, or reach the ground as a devastating impact or once the threat became credible. Sri Lankan authorities would have to coordinate with scientists and international space agencies. Emergency planners would begin studying possible impact zones and preparing contingency plans. The announcement would spread rapidly across Sri Lanka, Colombo, Kandy, Galle, Jaffna, Trincomalee, and communities throughout the island would suddenly be following the same story. The biggest question would be simple: where will it hit? Sri Lanka's geography creates a unique challenge. With a large population living across a relatively compact island, there would be limited space to move people away from a potentially dangerous region. Roads, railways, ports, and airports would become extremely important. As the asteroid approaches, scientists continue updating its predicted path. Every new measurement could narrow the impact zone. Meanwhile, emergency teams would have less and less time to prepare for the possibility of a catastrophic event. The asteroid enters Earth's atmosphere at tremendous velocity. Air compressed in front of the object becomes extremely hot, creating a brilliant glowing trail. Depending on its size and structure, the asteroid might fragment or continue toward the surface. Because Sri Lanka is an island, an impact in the surrounding Indian Ocean would be a major concern. The difference between a land strike and an ocean strike could completely change the disaster's effects. If the asteroid struck Sri Lanka itself, the immediate area would experience extraordinary heat and pressure. Rock and soil could be violently displaced, while a massive blast would spread outward from the collision point. A sufficiently large asteroid could excavate a huge crater and permanently reshape the terrain. Material from deep underground could be thrown into the atmosphere, while enormous quantities of debris would spread across the surrounding region. The impact would generate a powerful structures near the impact could be destroyed, while buildings farther away could suffer damage from intense winds and atmospheric pressure. If the impact occurred near a densely populated area, the destruction could involve homes, commercial buildings, roads, bridges, communications equipment, and other infrastructure. The density of development would make rescue operations, especially the collision, would send seismic energy through the Earth's crust. Strong ground motion could damage structures far from the impact site and create additional problems for already weakened infrastructure. Rock, fragments, and other impact material would be thrown upward before falling back toward Earth. Larger pieces could land relatively close to the impact site, while finer particles could travel much farther. Now, imagine the asteroid striking offshore instead. A sufficiently large collision could displace enormous amounts of seawater. Sri Lanka's coastline could face dangerous waves, with the severity depending on the impact's location, size, and distance from land, ports, fishing communities, coastal roads, tourist areas, and other low-lying regions could face serious disruption in an ocean impact scenario. The timing and scale of any waves would depend heavily on the exact characteristics of the impact. Extreme heat could ignite fires across affected areas. Buildings, vehicles, electrical systems, industrial facilities, and vegetation could all become sources of additional flames, making an already difficult emergency even harder to control. Damage to power generation and distribution infrastructure could create widespread outages. Without electricity, hospitals, water systems, telecommunications, businesses, and transportation networks would struggle to operate. Medical facilities would suddenly have to handle huge numbers of injured people. Hospitals outside the worst-hit areas could become essential treatment centers, but transporting patients would be difficult if roads and communication networks were damaged. Sri Lanka would depend heavily on functioning highways, railways, airports, and ports during the aftermath. Clearing damaged routes would be essential for moving rescue workers, medical equipment, food, fuel, millions of people would attempt to contact relatives and emergency services at the same time. Damaged towers and power failures could make the situation worse. Reliable emergency communication would become one of the country's most valuable resources. Sri Lanka's tourism industry could be severely affected. Airports, hotels, beaches, cultural sites, and transportation networks could experience major disruption. Even regions that escaped direct physical destruction could suffer enormous economic losses. Sri Lanka's agricultural systems could also be affected. Damage to farmland, irrigation, transportation, and storage facilities could reduce the availability of food. If a very large impact altered atmospheric conditions, agriculture could face additional long-term difficulties. Fishing and other coastal economic activities could be disrupted by an ocean impact or widespread coastal damage. Ports and shipping routes could also face problems, affecting the movement of essential goods into and out of the country. Sri Lanka sits in the Indian Ocean near major regional transportation routes. A catastrophic event could therefore affect neighboring countries through disrupted shipping, economic instability, humanitarian movement, and atmospheric effects. Although Sri Lanka's economy is much smaller than those of major world powers, a catastrophic disaster would still create regional and international consequences. Tourism, shipping, trade, agriculture, and supply networks could all. Countries and international organizations could provide emergency supplies, medical teams, rescue equipment, temporary shelters, and financial assistance. Sri Lanka's location as an island would make international air and sea support particularly. After the immediate destruction, rebuilding would begin. Homes, hospitals, roads, power systems, ports, businesses, and public infrastructure would need to be restored. The recovery could take years, especially if the asteroid were large enough to cause environmental effects beyond Sri Lanka. The most hopeful part of the story comes before impact. If humanity discovers a dangerous asteroid early enough, scientists may have years or even decades to respond. Planetary defense missions have demonstrated that spacecraft can alter an asteroid's motion, meaning early detection could potentially prevent a future impact from becoming a disaster. Astronomers detect a dark object moving through space on a path that brings it unusually close to Earth. At first, its significance isn't clear, but continued observations reveal that it could become a serious threat. Scientists calculate the asteroid's future position using observations from multiple telescopes. The predicted path begins crossing Southeast Asia, with Vietnam appearing inside the possible impact region. Researchers try to determine the asteroid's diameter, density, speed, and composition. These numbers would help them estimate whether it could break apart in the atmosphere or reach the surface with enormous energy. Once the probability becomes serious enough, Vietnamese authorities would begin coordinating emergency preparations. Scientists would provide impact projections while disaster response teams study which regions could be most vulnerable. People across Hanoi, Ho Chi Minh City, Da Nang, Haiphong, and other communities would begin following every update. The uncertainty could create fear, especially as scientists continued refining the predicted impact location. If the warning came early enough, authorities could attempt to move people away from the projected impact area. Roads, railways, airports, and waterways would become essential for moving large populations. Vietnam has a long coastline along the South China Sea. If the asteroid's trajectory pointed toward the ocean, authorities would have to consider the possibility of powerful waves and coastal flooding. As the asteroid approaches Earth, telescopes would continue tracking its movement. The object would become brighter as it entered the atmosphere, turning into a spectacular but terrifying sight across the sky. The asteroid would slam into Earth's atmosphere at tremendous speed. The air surrounding it would become intensely heated, producing a glowing trail and potentially causing the object to fragment. If the asteroid survived atmospheric entry, it would strike with enormous kinetic energy. The collision would instantly release tremendous heat and pressure, devastating the area immediately surrounding the impact site. A sufficiently large asteroid striking land could excavate a huge crater. Rock, soil, and debris would be thrown outward, permanently altering the landscape. A powerful blast wave would travel away from the impact. Buildings, vehicles, bridges, power lines, and other infrastructure could be damaged over a progressively larger area. If the impact occurred near northern Vietnam, Hanoi and surrounding communities could experience severe indirect effects. Transportation, communications, electricity, and emergency services could be heavily disrupted. A southern impact would create a different challenge. Ho Chi Minh City and the surrounding urban region contain enormous concentrations of people, businesses, roads, waterways, and industrial infrastructure. The Mekong Delta's low-lying landscape would be particularly sensitive to major coastal. If the asteroid struck offshore instead of land, the collision could displace a tremendous amount of seawater. The resulting waves would depend on the asteroid size, impact location, water depth, and distance from the coast, ports, fishing communities, industrial areas, resorts, and coastal settlements could be affected by powerful waves. The damage would vary greatly, depending on how close each location was to the impact at the extreme heat from. The impact could ignite fires across damaged areas, urban buildings, vehicles, factories, fuel storage, and electrical infrastructure could all contribute to secondary fires. Power stations, transmission lines, and substations could be damaged. Large-scale outages would interfere with hospitals, water treatment, telecommunications, transportation, and everyday life. Medical facilities would have to treat enormous numbers of injured people while potentially operating with damaged infrastructure. Hospitals outside the main disaster zone would become essential to the emergency response. Roads, bridges, railways, airports, and ports could all be affected. Clearing transportation routes would become a major priority because rescue teams would need reliable ways to reach isolated. Vietnam has major agricultural regions producing rice, seafood, fruit, and other products. Damage to farms, warehouses, roads, ports, and markets could interrupt the movement of food across the country. Manufacturing and exports could be severely disrupted. Factories, electronics production, shipping, agriculture, and international trade could all experience major losses if infrastructure was damaged. A major impact could destroy habitats and contaminate surrounding land and waterways with enormous quantities of debris. Coastal and marine ecosystems could also suffer if the collision occurred in the sea. If the asteroid were exceptionally large, huge quantities of dust and vapor could rise into the atmosphere. Some material could spread across Southeast Asia and potentially much farther. A large amount of atmospheric dust could reduce sunlight reaching the surface. If the effect lasted long enough, temperatures and growing conditions could change, placing additional pressure on crops. The consequences wouldn't necessarily stop at Vietnam's borders. Disrupted trade, shipping, migration, food supplies, and atmospheric conditions could affect neighboring countries throughout the region. Countries and international organizations could send rescue teams, medical supplies, aircraft, ships, food, and emergency equipment. Coordinating assistance would become a massive international operation. After the immediate danger passed, rebuilding would involve homes, hospitals, roads, bridges, ports, power networks, factories, farms, and communication systems. Some areas could require years of reconstruction. The most important opportunity would come long before the asteroid reached Vietnam. Deep in space, an observatory detects an object moving unusually fast. At first, scientists don't know whether it poses any danger. After several nights of tracking, however, its trajectory starts looking increasingly concerning. Astronomers combine observations from different observatories to calculate the asteroid's orbit. The calculations show that the object is heading toward Earth. Even more alarming, the projected impact corridor passes through China. Once the possibility becomes credible, the situation turns into a race against time. Scientists have to continuously update the asteroid's position while authorities begin preparing emergency plans. Every additional observation could improve the accuracy of the predicted impact location. Chinese authorities would receive information about the potential threat and begin coordinating with scientific and emergency organizations. The government would have to decide how much information to release and which regions might need immediate preparation. The announcement would spread rapidly across television, smartphones, social media, and news platforms. People in cities across China would begin wondering whether their homes are inside the danger zone. Panic could spread almost as quickly as the information itself. China's enormous transportation network could become crucial during preparations. High-speed railways, highways, airports, and other systems could potentially be used to move people away from the predicted impact region if enough warning were available. As the asteroid approaches Earth, its apparent brightness could increase. Scientists would continue monitoring its trajectory while people around the world watch the approaching object. At this point, there would be no room for careless predictions. The exact impact location would matter enormously. The asteroid finally reaches Earth's atmosphere, traveling at several kilometers per second. It compresses the air in front of it and generates tremendous heat. The surrounding sky could briefly become brighter than anything normally seen from Earth. The asteroid reaches the surface and releases an immense amount of energy. The surrounding ground would be violently disturbed, while temperatures and pressures near the impact point would become extreme. Within moments, the impact would generate a powerful blast capable of affecting an enormous region. The closer an area is to the impact, the more severe the destruction would become. Buildings, roads, vehicles, and other structures could be overwhelmed by the tremendous forces. A large enough asteroid could excavate an enormous crater. Rock from below the surface could be launched upward, while huge amounts of soil and debris would be thrown outward. The original landscape could become almost unrecognizable. The atmosphere would carry the impact's shockwave across the surrounding region. Structures farther away could experience progressively weaker but still potentially damaging pressure. Windows, roofs, power infrastructure, and other vulnerable systems could be affected over a wide area. If the impact happened close to a major Chinese population center, the consequences could become extraordinary. Dense development and massive infrastructure networks could mean that a single impact disrupts transportation, communications, energy, and emergency services simultaneously. Material thrown into the atmosphere would eventually begin returning toward the surface. Larger fragments could fall relatively close to the impact area, while smaller particles could travel much farther. The danger would therefore continue. Even after the initial explosion, the collision would send powerful seismic energy through the Earth's crust. Ground movement could damage already weakened infrastructure and create additional problems for roads, bridges, tunnels, pipelines, and buildings. China has an enormous coastline, so an offshore impact would create a very different scenario. If a sufficiently large asteroid hit the sea, The displaced water could generate powerful waves. Coastal areas could potentially experience severe flooding, depending on the impact. Conditions. Extreme heat from the impact could ignite fires. Industrial facilities, fuel storage, vehicles, electrical equipment, and buildings could all provide additional sources of fuel. Fighting widespread fires would become especially difficult if roads and water systems were damaged. China's vast electricity infrastructure could experience severe damage in the affected region. Power stations, transmission lines, substations, and distribution networks could fail. A prolonged blackout would make almost every other emergency more difficult to manage. Railways, highways, bridges, airports, and ports could be affected by the disaster. Even infrastructure that survives the initial impact could become unusable because of debris, power failures, or damaged control systems. Moving food, medicine, and emergency equipment would become increasingly difficult. Medical facilities would have to deal with enormous numbers of casualties while potentially operating without normal electricity, communications, transportation, or supplies. Hospitals outside the worst affected region would become essential for treating people evacuated from damaged areas. During the aftermath, people would desperately need reliable information. Mobile networks, internet connections, broadcasting systems, and emergency communication channels could experience heavy demand or physical damage. Authorities would need alternative methods of reaching the population. If the asteroid were extremely large, the impact could send enormous amounts of dust and vapor high into the atmosphere. Some material could remain suspended and spread across large distances. At this point, the event could begin producing consequences far beyond China's borders. Large quantities of atmospheric particles could interfere with incoming sunlight. The skies could become unusually hazy, and the amount of solar energy reaching the surface could decrease. The duration and severity of this effect would depend on the scale and nature of the impact. China supports a huge population through extensive agricultural systems. Changes in temperature, sunlight, rainfall, and atmospheric conditions could create serious challenges for farming. A prolonged environmental disturbance could reduce crop production and place pressure on food supplies. China is deeply connected to global manufacturing and trade. Damage to factories, ports, roads, railways, warehouses, and energy systems could interrupt the movement of products around the world. Industries on other continents could suddenly find themselves missing essential components, electronics, machinery, consumer products, industrial equipment, and countless other goods are connected to Chinese production and supply networks. A major disruption could therefore create shortages and delays across international markets. A catastrophe affecting one of the world's largest economies would create enormous uncertainty. International stock markets, currencies, commodities, shipping, insurance, and investment could all experience major turbulence. The economic effects could continue long after the physical disaster. The international community would face a huge humanitarian challenge. Other countries could provide medical supplies, rescue equipment, food, financial assistance, and technical support. International organizations would also have to coordinate relief efforts on an unprecedented scale. Once the immediate crisis ended, rebuilding would become the next enormous challenge. Cities, transportation networks, industries, homes, hospitals, and power systems would need to be restored. If the asteroid caused global environmental disruption, recovery could become even more difficult. The terrifying scenario ultimately leads to one important question: could humanity prevent it? Early detection is the key. The sooner a dangerous asteroid is discovered, the more options scientists have to change its trajectory. Missions such as NASA's DART have demonstrated asteroid deflection technology, showing that planetary defense is no longer purely science fiction.